Good afternoon, everyone. Look excited. This is right after lunch. Okay, this is the rantings of an almost old guy because, you know, none of us are ever going to be old, not in this field. This is basically 30 years plus of my experience. And as we get to the end of this, you'll realize that nothing's really changed, nothing's really new. But actually understanding some of the core values we have in security and why, again, things haven't changed might help you with your career. And I also have some career recommendations towards the end, and also some futures that we're going to look forward to maybe hack. So who am I? I'm an asker of questions and a question of answers. Yes, when somebody has a question, I'll answer it, but then I'll have additional questions, and that becomes very interesting. I've explored physical, psychological, virtual, and spiritual spaces. Yeah, okay, I've never talked about the last couple. Consumer of hardware, software, wetware standards, and interpretation of standards, code documents, and presentations. What I'm saying is, I do deep dives on technology. A couple nights ago, I couldn't sleep. So I started rereading the NTP standard and then found some really cool reference documents and then spent the next 3 hours doing this. And my girlfriend tolerates this. I don't know why, but you know, that's how it goes. I've actually been part of IEEE standards creation, IETF standards, military standards, blah, blah, blah. So it's pretty interesting. And also a gather of a lot of information, knowledge, interpreting. That's one of the fun things if somebody has a long view like Jack and I. As you can see trends occur, not just today, but things that happen tomorrow and the next year and the following year and things like that, which, by the way, all makes me a hacker, at least according to current definitions. So in the beginning, I have been interviewing people that are my age group. And I said, so, what got you excited to get into this field? Did you know most of us did magic? Mitnick says magic was the one thing that he thought was pretty cool, especially as he started implementing or playing with technology. He realized it's magic too because nobody that actually uses it understands it. Most of us got code and cipher crackers. If you talk to anybody that's doing crypto early in their life, they did that. Most of us got access to this kind of stuff and started playing and this kind of stuff, and then this stuff to actually ask us to teach about photography and other things. This was, you know, 50s, 60s, and 70s kind of technology that we were looking at. So I was motivated by 2 television shows back at that point. One was called It Takes a Thief, and one's called Wild Wild West. And during both of them, they actually showed that people could get through doors. And, you know, being 9 years old, I went, nobody could get through doors, but they had these little pieces of metal, and they had these little pieces of plastic. So I went after a door that looks very similar to this, and I wiggled and I wobbled, and, you know, several hours later I got in. I went, this is pretty cool. Is it repeatable? Can I do it again at that age? And yes, I did. And I went, this is pretty cool. So I started looking at other doors and started questioning other doors. Again, figuring out how to do it with these based on these video presentations that really didn't go into the details of them, but I started, you know, inquiring about this. And yes, I learned about running around different spaces. I probably didn't say do not enter, but probably shouldn't have been there. Lessons learned. If you have enough time, you can get into anything. And you can figure out what the tools are, you can get into anything. Does anything changed today? Nope. Security is only good as the specifications, the installation, and the interest of management and the maintainers to maintain that security. Has anything changed since then? No. And really, this is something I actually, does anybody have kids? Anybody planning to have kids? Anybody practicing to have kids? No, just kidding. So one of the things that now I teach kids, I've been part of Hack Kid and some of the other events, is to learn how to lockpick. Why is that? We create this mental barrier about what that magic key means to us. We can't get in the house without that particular magic key. Once a kid actually is taught that there are no limitations except for your time and effort, they start thinking like a hacker, which becomes very interesting because then they will get involved in technical and learn how to program, and they just start, doing some really amazing things. But I teach this on a regular basis when I get a chance to sit down with kids and even adults. I had a friend of mine, she's almost my age, and I have a 2-pin lock, and I showed her how to pop the lock. And she went, "No, this is impossible." So I get a call from her that she got locked out of a house that she had rented in Alabama, and she just basically picked the lock and got in, and her sisters and stuff were locked out too. So she got in, and they went, "You're magic, you're amazing." Things haven't changed in this technology. They really haven't. So my first hack, a Primus computer. Yes, I had to play with these. These were really cruel. Hanging chads were just not a problem because it was a lot. You basically had to make sure it was poked in. And this was the terminal or equivalent to the terminal that I used. And this was the gear that I ended up playing with. Well, there was this game, there was this television show called Star Trek. And I went, this is really cool. And they loaded the software on this computer. This computer, by the way, only had a whole 16 meg worth of hard drive, and that was really, really expensive. And it had 32K of RAM. Okay, so I started mucking with it. And I realized that I was losing. I don't like to lose. So I started mucking with it a little bit more, and I found out that I could change the code, which was an undocumented feature. And I changed the code so I had dilithium crystals every time. So I pressed a button, I had extra power, life was good, I beat it. Well, then I went to the system admins, and I said, look what I did, this is really cool. Have you ever gone to somebody and told them they have a vulnerability? That first look on that face is, amazement. And then they're appalled that you mess with their system. And then they're angry that you mess with their system. Well, they were the whole thing, and then they made me responsible for the security of the system. No good deed goes unpunished. So some of the lessons. Motivated people can compromise systems. In this particular case, I found the application was running as administrator because there wasn't any concept of administrator and non-administrator on the system. How many people still run their operating systems with admin privileges as a user? It's a big problem. Nothing's changed. And also the application had a backdoor. Apparently some kind person from the university that created this put a backdoor so they could get dilithium crystals. That was after reading the rest of the code. So again, things haven't changed. Okay, the ex-girlfriend. I won't go into the details, but she became an ex-girlfriend. And I realized that at that point, again, this is years ago. Anybody want to figure out the year? 1978. So I was really young. I had hair then. Anyway, we won't go into that. I had not all this extra padding. This takes some time to get. So I realized that we all had presentations to give. And they gave us a default pattern for passwords. And I went, oh, this is pretty cool. Oh, crap, everybody can use it. So I figured out the pattern, and that was kind of cool. And then I said, it would be far more fun to collect passwords if I just wrote a script that said login, password, and then I died. So I went around all the little screens and did that. And I collected everybody's password, including the ex-girlfriend. And then I realized that there's login scripts. Does anybody use Linux login scripts and logout scripts? I realized I could do things. I was kind of angry with her because I caught her and everything else with somebody. So every time she logged out, it took her code and modified her code. Okay, that was not really nice of me, but I was kind of young and stupid and things like that. So anyway, she dropped out of the class. I don't understand. None of her programs seemed to work. So lessons learned. Again, default well-known passwords can be compromised. Have we solved this problem today? Anybody? Anybody? No, we haven't. Okay. Startup and shutdown scripts can be evil, can't they? Anybody, have we fixed that yet? How about backup? Do we back up our software to a backup manager or offline? Do we still do that? Do we have policies to do that? Do we make sure our people do this? Not quite. So things still haven't changed. Then, I started working for a company that did these and did these and did these and did these. And I went, these have got to be secure. They're physical systems. They could hurt people, right? So I got access to a couple of these. And I realized the coding was only 8 bits. 256 potential options. Wow. That would be really hard to flip the little switches, but what if I took some electronics and took a 555 chip and a serial to parallel 8-bit converter, and now I could press a button and actually it would count all of those bits. It would count up, and it would send enough signals to open everything, right? Well, it worked really well. Sorry. Whoa. It worked really well. I was able to open these and open these and open these and these too. I went and talked to all the vendors. They had the same response, which was interesting. We were able to solve some of the problems. I also, at the time, I also found physically these card readers had relay switches that nobody ever thought if they took their hand and went pop, the relays would close and the gate would open. Okay, so they had to remount them and change the chipsets and things, the relays and stuff like that. The same thing with the stops here and the stops here. So physically, this stuff hasn't changed a lot. Yes, okay, now they have some crypto code here, so that's solved, but have they solved the rest of these Internet of Things problems? I don't know, I haven't investigated them since 1981. Has any of this changed? Oh, some lessons learned. Access to radio transmitters should be restricted. Well, anybody use software-defined radios? Okay. When applying radio receiver problems, you need to look at safety and security. You shouldn't basically just throw wireless on something if there's safety and security involved. How many systems involved today, safety and security? Have you taken a look at the car-to-car communications? Enough said. Okay. Security cards, because they have to be secure too, because we know that somebody took the time and the effort to make sure that nobody could actually open any of this stuff. Okay? Well, I got a call from a customer, and the customer said, we've got this card, it didn't have the little dots on it, and we don't know, because they had taken off the little badge thing here, we don't know what the code is so we can order these cards to let people in and out of this well-known building that maybe be managed by the federal government. You know, can you have somebody take a look at it? This is 82. At that point, they were so cool with the technology. These were actually embedded magnets. So I took a plus and a minus magnet and I flipped it around to figure out and put a little magic marker on each to figure out what was plus or minus. And then I punched them out, and I figured out where all the dots would have been, and I created all this magnet thing. So I was able to actually take this card and create any type of, to replicate any type of card available. Even found another card that had a minor change, and I found out it was a facility code. Was able to do it, and the customer was kind enough to thank us because they paid us, and they were able to get their cards. Okay? Anybody see any change to this with, say, barcode or any of the other reader technology we have today? So, obvious indicators of security lead to questions. Each of the places on the card had bumps. And I went, there's bumps here. Something's got to be hiding in here. So after taking a couple cards away, we flipped them around, we found problems. Also, the cost of technology is becoming less expensive, therefore attacks are increasing. We're seeing this with everything today. Apparently, there is no model that currently exists, unless somebody knows of it. When I implemented technology, when's the estimate of the cost of that technology going to decrease to the point that every consumer has access to it? There is no system currently. Automobiles, anything that moves, any of the other technology, this is a big problem. This isn't even part of when we specify the system. When do we estimate this technology is going to become cheaper? So again, more lessons we haven't learned. Okay, then I got to play with physical security again. With another company, I got to learn how to muck with these and these and these and these, and yes, those too. I learned a lot about these systems. Many of the systems had coding problems that they had never tested. They had backdoors in them that nobody actually found until you started reading the documentation. We also found these devices didn't have the accuracy that they expected. If I had 60 numbers on something and I was turning it, it was 60 plus or minus one digit. Okay, that's kind of disturbing when you're expecting a resolution of 60 and you find out it has 1/6 or 1/3 that resolution when I remember the numbers. Okay, again, no expectations, or you're supposed to have expectations of what the security means, but it doesn't. And yes, I went to several banks, and this is what I found. Okay, they were big tube monitors, but basically cameras behind tube monitors. This actually exists in nature, well, in our buildings. Oh yes, and this, one of the installers of one of these systems was kind enough to put the electrical box here and leave it unsecured. Okay, and one of the installers of this used Scotch tape to connect everything. Okay. So from a security standpoint, the product guides contain default everything. Maintainers have little time. You're supposed to go touch X amount of products per day or X amount of customers per day. You don't have a chance to actually spend time and clean this stuff up. So after generations and generations of just plugging this stuff in, you find all kind of problems. And the maintainers and companies don't control access. We keep on seeing default passwords for physical security systems discovered in every product that's out there. Okay? Again, things haven't changed. Is this useful for you guys to actually see that this technology? Mainframes. Yes, indeed. They were fun. This was 86. So, I was doing a COBOL program. And we were supposed to play with recursion, which means that, you're supposed to go so far and have an endpoint. Well, I asked the question, what would happen if I never stopped when I was calculating? That's when I learned about DDoSing CPUs. They were very unhappy. They had to reboot. They were very unhappy. Apparently, the way it was configured, there was not a default endpoint that it would put in. There was no endpoint for this. And every user was running as trusted user. There wasn't actually a non-trusted user space. So that was a real problem. So lessons learned, yes, any language can do recursion, including COBOL. And yes, you can DDoS if you allow the trusted space access. So then, wow, I found out the mainframe had networking. What the heck was that? We had SNA. And we were connected to the global SNA network. Well, I received an email. I went, wow, this is pretty cool, and it's not even from our facility. And I opened it up, and it was a challenge. It said, if you're a male or you're a female, please take this test. We're doing data collection. Well, this was pretty cool, and they had some really obscene, obnoxious questions, yes or no, yes or no, yes or no. And then you would press the send. Well, yes. Malware, I learned about malware in that year. The result of this malware is it DDoSed the receiving system's email server, which took down another facility's email server. That was really bad because it filled their storage. And anyway, so yes, malware exists on all systems and can be used for DDoS. This was 85. Mainframe again. Wow. So after doing all this stuff, the professor said, you know, you're going to have to knock my socks off to get a really good grade after which what we found so far. You're going to have to knock my socks off. And I went, okay. So I started looking for books and manuals, trying to come up with a new idea of what I can do. Well, I found this set of codes that allowed me to walk memory from the very top to the very bottom. And I realized that they were all producing their finals on the computer at that time. This can't be a problem, right? So my deliverable was the code to walk memory and what the finals were for 3 of the professor's programs. Again, they were a little bit angry, but what they ended up learning was, again, non-trusted memory. Yes, and I was responsible for the security of this system too, again, unpunished. Again, there was no laws at this time. So we had unauthorized access to memory space, causes disclosure, and yes, I really hate xEdit, although I use VI today, so I'm not sure what that says about me. So in '86, we found that, guess what? There was this 3B in there. I'd been playing with fortunes at home. Somebody actually dropped off a fortune computer, an old BSD, and playing with it and having a great time. And yes, this is what it looked like. Yeah, this was VisiCalc. Anybody remember VisiCalc? Okay, we know you're old. Well, this is what a 3B looked like. Well, after discovering some things, the power button actually did an init6. It actually rebooted, it actually pressed, it called the script for init6. And I went, that's pretty cool. What other init levels are there? So I started exploring that. And then I found the Etsy password file. At that point, the Etsy password file wasn't encrypted. There was no shadow file. So I didn't look through the passwords. I went, I wonder if the password patterns were guessable. And yes, they were guessable. Real big problem. And then I got early access to internet in '86. I was hooked. Okay, so I've been on the internet since '86, learning, exploring, looking at the networks, trying to get people to fix things. Very interesting. So yeah, the algorithms that we create still are guessable. I'm sorry, 5 characters or 8 characters one upper and lower case, use a word that's easy to remember. We have dictionary attacks that we've been using for years. Nothing's changed. We have to change this process. The only thing that's changed, by the way, remember I told you about the Primos system where I was able to put a script up to look for logins? On Unix this year, we were able to hold down the Control-Alt-Delete, and it forced a reboot of the system so I could kill all the actual applications, the console. So if any programs were running instead of me having direct access to a login screen, that changed. So that was really, really cool. Yes, DEF CON. Yeah, I started doing DEF CON. Well, somebody put up a wireless sniffer. This was 2000. Yeah, there was a lot of things that happened in the 90s. I won't go into those. Things like capture the flag on our own computers, which led to things like people finding a vulnerability in Solaris box that allows you to run sounds to somebody else's Solaris box. So as a joke, these guys started doing this as I'm sitting there coding. But they send Godzilla stuff to it. So I'd hear, and I'd get up, anybody, what's going on? At the same time, they thought it was funny because they took my lock and they turned it backwards, so I had to knock on the door to get out. Okay. So, hackers do interesting things. We also played Capture the Flag based on the Core Wars code that came out. So we basically tried to destroy a system. Again, these were our systems that we were using, and we made them unusable. We'd have to reload them, which took a lot of time at this point. Okay? So there were a lot of crazy antics and things like that that we learned about computers. We've learned X Windows had back doors. Has anybody looked at the X Windows back doors that still exist? There's a lot of them. Okay? We saw shell shock. At this point, I was creating websites in 92, 93, and as one of my capture the flag things, somebody went into that and changed my variables, my environmental variables, and got access to my system. That vulnerability's existed for years, okay? And it's existed in every shell. The problem with it is, my big mistake is I didn't validate variables coming into the system, okay? There's a lot of those things that the old guys like myself, well, almost old guys. Wait a second, I think you're older than me, so I can call you the old guy. Oh, just kidding. So this has existed for a very, very long time. For the DEF CON things, early on, 2000, 2001, we started seeing people sniffing traffic. Well, these guys were sniffing traffic and they said, hey, this is kind of fun, but we need to document this some way and get their pictures. So I ran over and grabbed a whole bunch of paper plates, and we started taping paper plates up and writing the username, passwords, and where they were going on these. And then we were running around and trying to find each of these people so we could get a picture of them. Clear text, wireless. Remember I said wireless is bad if you don't understand it? And we were running around and doing this. We had a ball doing this. Okay? So again, wireless can be, kind of dangerous. We also saw this van that had apparently cameras and stuff in it that were facing out to watch people. We found that yellow sticky notes all over that van made it look like a big canary. Okay, so, that was kind of interesting. And another strange story. Does anybody know FX? Felix? Okay. Again, a strange hack. We went to a hotel similar to this. And we walked in with 24 packs of beer, and we sat right down in the lobby. What do they do when you have 24 packs of beer in the lobby? They say, sirs, you can't have that in here. So with FX and a whole bunch of us sitting in Lexus Park, we checked them as if they were baggage. Then anybody wanted a beer would have to go check our bags. They would take the little slip. So we had the bag guy being our bartender. Okay? So again, out-of-the-box thinking is real important. I was also at pool 3, and this young lady decided that she wanted to go for a swim, but she only had panties on. She didn't, well, anyway. So we used the badges and we turned it into a bikini top. And again, DEF CON is a good place to, it's a security conference that allows you to be real creative, meet a lot of people, challenge yourself. I'm just not giving you the code stuff that I did or the other things. I'm trying to give you the social engineering stuff because that's been kind of cool and yes. So you have to really challenge yourself with this technology. You have to ask questions. You have to, go beyond. The biggest question I learned was these two guys had this thing called IPv6, and you've probably heard me talk about IPv6 before. And I had, yeah, shut up. I've been focused on this for 14 years. I've been focused on this because these two guys challenged me. We were sitting at dinner and they were saying, well, we can do this with IPv6. And I said, well, I broke that. Let me show you how I broke that. And after 3-4 times, what they said is, hey, Joe, you're evil. Really? So I said, so what do you propose? He says, why don't you figure out how to fix IPv6? So for the last 14 years, I've been spending my time. I have done almost 1,500 presentations during that time, a lot of them in the last 4 years. I've taught classes, I've written RFCs, I've done all kind of crazy stuff. I thought I actually could make a difference in this domain with this technology. I'm not sure if I have, but I learned a couple lessons. And again, this still touches what we do today. The ability to fix a technology, no matter what the technology is at odds with management goals for the corporations that you are in and the products that are being sold until somebody is embarrassed. Okay, FX talks about this in a recent presentation, is that we went from full disclosure, which embarrassed the company to fix things, to responsible disclosure, which gave the vendors the capability of waiting, in some cases, up to 13 years to fix vulnerabilities. Can you imagine how long we were all at risk from a network attack for 13 years? This vendor hasn't told you. They fixed it 2 years ago. Okay? That now we have gone to the third mode, which is the vendors, these billion-dollar vendors are going, please help us for free or pittance. But on the other side, a lot of people are now saying, these are billion-dollar companies. They should at least pay, comparable rates to do this stuff. Some of us are now turning around and actually just selling these vulnerabilities. So we've actually gone down a really bad road in this domain right now to protect people from corporations from being embarrassed. So be aware that we're seeing a lot of fighting and arguing in this field. Some people may believe that one of the three will happen or it's best for whomever. But if you spend 150 hours finding a vulnerability and then you get a call from a vendor, hey, can you come in and for your time and free, can you tell us how this is fixed? Does that have any return on investment for you guys? Okay, especially if maybe they only give you $100. Okay, and they don't pay you for your flight or anything else. So this is a real frustrating thing for many of us at this point. So this is basically a lesson I guess we as an industry still haven't learned is some of us really want to fix this stuff. How many have actually gone to a vendor to try to fix this stuff? Yeah. The current cost of a vulnerability, if you're a researcher and it's embarrassing, it could cost you $90,000 in legal fees if you disclose this. Or you could get $100 if they find out that, they like your vulnerability. So anyway, this is a disturbing lesson that I'm still dealing with. Also, your future. GMark's a friend. This is actually a card that GMark put together about this field. about your career in this field, and I just thought it was a good thing to reflect to. He spoke at this at TourCon 5-6 years ago, but you know, ask questions. You're expected to ask questions in this field, no matter who it is. Ask me questions. I mean, challenge me, please, on whatever I know. I get better, you get better. Don't wait for perfection. Put technology out and have it tested by people that are trusted. Do something, write something, just go out and do it. Oh, sorry, it was probably trademarked. Sorry, erase that piece. Become a master at something. Find something you're passionate about, my IPv6 stuff. Go out and challenge yourself to become, you know, it may be knowing the 853 where I can actually say, you know, N23 or N12, and you'll actually know what it is and you can actually solve that particular problem. You know how the solutions for that. Visualize everything. Never disqualify yourself. If you come in here and you see a wireless challenge, you've never done wireless, go to the wireless challenge. Try it out. This community is very supportive of you guys learning stuff. You know, no matter what it is, go learn it. Go try it. You may find it's a passion. You may find it's kind of cool and you can have a discussion with people about what some of the problems are. Just go out and do it. I mean, who knows? Maybe you could car hack. Let's see, challenge your limitations, have a vision, write it down, go forward with it. Speak at every chance you get. One of the big things I do for my mentoring for people that I've chosen to mentor is go out and teach them how to speak. Support them how to speak. If you're somebody that wants to mentor, this is really important. I have friends that are now well known in most fields and CSOs that have basically poked at them for a couple years to finally speak, to actually challenge themselves to do this, and now they're well recognized. You know, so, and also for yourself, go challenge yourself. Go take a friggin' a Toastmasters class, get comfortable with it. People want to kill themselves to get up on this stage. It's kind of fun. Look, you get all this space, you can walk around, and you can talk and rant. It's good. So go challenge yourself to do that. Be flexible, aim high, be passionate about it. Obviously, you can see I'm really passionate about this stuff. I actually gave a 4-hour presentation last Friday on minimal sleep, and people said, how do you get all that energy? It's coffee. You know, 20 minutes of sleep, coffee. Choose between tech and management. I found that as a mistake that I made for a while. It was management, and then I realized that they get rid of management. Managers get rid of other managers, but they never get rid of techs. So be aware that you have trade-offs you have to make. Do something bigger than yourself. Go get involved in one of the hacker spaces. Nova Labs is doing some really amazing things right now. Same thing with Hack DC. Go get involved in those and learn some things. Have that vision. Don't save the less for the best. I am a little bit older. I'm still out there doing really fun things with kids and younger people and things like that to learn. I mean, get out here and continue doing this and enjoy life. I mean, this is fun stuff. So that's career recommendation 1. Career recommendation 2, here's your challenge if you choose to accept it. This is the Internet of broke things. All of these things are already broke. I've tested a lot of these things. I've said, holy crap, to what my findings have been. Each one of these, and by the way, this is just IT. This is what all we've been doing up to this point, most of us. Each of these technologies have major problems. We've seen presentations that, on and on for the last 4 years, 5 years, on SCADA devices, of compromises that are available in all of these things. Go out and challenge yourself, become a subject matter expert on this stuff, learn how to protect it, learn how to attack it, learn how to protect it. We've got to actually fix this technology because, you know, transportation, health systems, industrial, these are all people's lives. Not just one of us, but all of us. Okay? Go challenge yourself. Lastly, defense in depth. It's such a cute, wonderful little thing for the CISSP. But honestly, insanity is called doing the same thing again and again and expecting different results. We put up a firewall, we get attacked. We put up anti-malware, we get attacked. The technology ages very quickly. So essentially the turtle, yeah, it's your network and systems. It sits still, it doesn't move. It's got all of its things in hiding. You know, the guillotine operator, that's the attacker. They always win right now. I'm tired of doing that. Okay, so I've been red team and it makes it too easy to win. I actually want to see us win on the defense for a change. The guillotine is really a lot of automation. We're now seeing things that we used to 30 years ago. Somebody would sit at a console. Now we're automating those scripts. Typical compromise, how long does anybody know how fast a typical compromise before an exfil can start? About 100 milliseconds. Think about that. If your SIM responds in 20 minutes, how much data can be transferred before you can stop it? Okay, so these are things to think about. And yes, gravity is the inevitability of your compromise. Defense in depth was actually a biological strategy. It worked really well when we were mammals trying to get through the ice age. We just kind of hunkered down. We knew that there was a bunch of us that were going to die. Okay, that's where we are right now with defense in depth. We need to change those strategies. We need to start learning from biological systems to defend ourselves from this stuff. Because currently, we're not winning. I don't like to lose. Did I mention that? I don't like to lose. Well, I don't like to lose from a defense standpoint either. Okay? That's it. Again, this is a rant to kind of provide a history that we haven't moved a lot in the last 30-some years. We haven't made a lot of improvements. We've made little tiny improvements, but really haven't made the big improvements. Any questions? Oh yes, and by the way, this was all old enough that it doesn't impact any of my other work that I've done recently in the last 12 years. Any questions, comments? Please. Just like you, a little bit crazy. Okay, I see you at every conference too. Okay, you get up in the morning and go, I think I may have an idea. I just had an idea on a new way to stop DDoS attacks that I just went and did a article review and I didn't see any way of using this technology to do that. I thought that was pretty cool. Now I'm going to investigate how I can actually make it a little bit of a difference at this point. But this is fun technology, and let's be honest, we all get paid pretty well with this technology. So, you know, the payment and the possibility that we may be able to find some of these solutions, they may be point solutions, but, you know, we're still actually making a little bit of a progress at this technology. Any other questions? Please. No. I did know that I like challenges. I like puzzles. I like magic. I like challenging myself. This is the most challenging field you can be in. There's actually been studies in the last year that this is the most intellectually challenging career you can have, period. Okay? That's pretty amazing if you think about it, that you guys are actually part of something that is that just incredibly difficult and challenging. No, I started as a double E, started as an electrical engineer, and it killed my program for electrical engineering. I had to go to computer science. And I went, okay, this is kind of fun. I get to play with the bits once they've come out of the electricity, yeah. So, no, I didn't know. And a lot of these things have been conversations with friends. Hey, have you considered looking at this? presentations from GMARC, presentations from Jack. You know, show up and watch these presentations. Show up for conferences. You're going to find a lot of things. Something that may just percolate with you and go, oh yeah, I want to solve that problem. That's cool. Or, I could bring that back and do something interesting with it. So no, it's not been a defined path that, you know, it's not like being an accountant where you know your defined path. This is, you guys get to make your own path, seriously. Does that answer your question? Okay, just be passionate about it. Anybody else? I know there's people in the back with hoodies on. Dude, you're so bad. I've seen pictures of you with the hoodies. Any other questions? Sir.
You mentioned the ability to fix technology being at odds with management goals and the process of very tonight.
Yes.
Do you have any ideas about
wait a second.
Do you have any ideas about how to reconcile that issue given the frequent focus on meeting this quarter's numbers?
Funny you asked. I was just talking to some people. Actually, a bunch of us were chatting. Our challenge right now is we need to fix this stuff long-term, not short-term, on a quarterly basis. The other challenge, like I presented on Friday, is certain management is now my age or Jack's age, and they're expecting to retire soon. They don't want to rock the boat. They want to get their bonuses. They want to walk away. Unfortunately, we're seeing some organizations failing. Did you hear about the law firm up in, how many minutes? 4. Did you hear about the law firm up in New York? It got hacked. They're out of business. Nobody wants to even hire the lawyers that work for them because they felt like, you know, they lost all their customers' information, all their clients' information. They can't trust any of these individuals. We're seeing that with Target. We're seeing that with a lot of other people. I think we need to get over the embarrassment side of it, the stages of grief, and we need to start taking action on it. Currently, what I do with some management is I try to educate them that it's better to get ahead of the problem instead of getting attacked by the problem, and also understand that every technology you put in, you have to put maintenance on it. You have to put somebody looking at it. NTP servers. Has anybody updated your NTP? That's usually been sitting out there for 15 years. Nobody patched it. You know, your DNS servers. You know, your database servers. All that stuff needs maintenance. You know, people have to check it on a pretty regular basis now because we're seeing attackers go after this stuff.
You mentioned that our response should be more like a biology response. Now, when I think about this now that you said we need to fix stuff, this is exactly not how, for instance, a biological system works, right?
Correct.
We do not fix people. We encounter the plague, a lot of people die. The others build immunity about this thing, right?
That's where we are right now. Yep.
Virus can't get to us, right? So why actually should we try to fix all this stuff? If I look about the last 20, 30 years or so, we did amazing things.
Yes.
There are a lot of amazing
Oh,
things.
hold on a second.
So we did, over the last couple of years, amazing things over the last 30 years. And the things that are actually not working so much. And come on, the girls, the law firm broke. Who actually cares in the big scheme of things? So I wonder if this idea that fixing it and also trying to be more like a biological system is not really comparable.
No. We're going to actually be forced to do both. First, we're going to have to hunker down and fix some of this stuff, but we need to start implementing biological protections. Right now, we see very few products, if any products, that are actually out there dealing with biological defenses, offense, and methods right now. We've seen recommendations from MITRE, Carnegie Mellon, people like that we need to move into this particular domain. We need to know how to respond instead of stand there and take an attack and get beaten down. So unfortunately, we're forced with doing both. but we also have to have products that are ready to do this. We can't just have a product that makes a change every once in a while to look for a regex that's on the wire or on a computer, or a whitelist that somebody can get past. I mean, we have a lot of this stuff happening. We just have to start using behavior-based systems instead of regex. We need to start, looking at how the attackers, the next step the attackers are going to take when we're putting a protection in, not just trying to fix this problem, but deal with the next one and the next one. Does that make sense? We need to start playing chess with these attacks. I just got cut off. If anybody has a question, I'll be outside. Thank you for your time.